In this last video for your keychain project, I'm pretty sure this is the last video you'll need. I want to show you a concept that we need to learn in order to send our design to the actual machine. The CNC router machine in the back of the classroom does not understand vCarve files. It doesn't know what to do with all of these CAD and CAM settings and vectors and stuff like that. Excuse me. I'm going to go back to something familiar. I hope it's familiar. If I was using a word processor and I wanted to print this, I would probably load up the printers or something, and you've done this at home. When you say to print, um, you can call up the printer, and what will happen, say for example in the school, there's different printers that I can send it to. Each one of them is a different type, whether it's a main office Xerox printer, or it's a Microsoft printer, or it's a Hewlett Packard printer, or whatever it is. But I have to send it to specific printers. When I send my document to a printer, I'm sending it through a translator for my printer, whether it's the Xerox translator, the Canon translator, the Hewlett Packard translator. In technical terms, it's called a post processor. The printer driver or that printer software you would load up is called a post processor. It processes or translates your document for that printer. So if I, pardon me, if I wanted to send this to a specific printer, each one of the translators or post processors would sort of jumble it up a different way. Well, similarly in vCarve, we have to get our program and do a post process on it, translate it into a file or a format that the CNC machine at the back can understand. I'm doing a really simple example because some of you math geeks want to know these things. Let's imagine my piece. This is the white piece, the piece of material, wood, steel, whatever. I set it up at 4x2, and it's a 1/4 inch thick. Remember, I started at my origin in the corner, and I'm going in inches. For this border, I modified it, and I got rid of everything else, just a very simple border, and it's 3x1. I want you to remember those numbers. 4 inches across, but the border's 3. If I start in my origin, I have to go over an inch and up an inch. Then I put the cutter down, and I'll go around over to here, back down and across. So if that's 4 inches across, and I come in, this will be coming over a 1/2 an inch, and this is a 1/2 an inch, so this ends up being 3 inches. So watch what happens. In order to do a post processor for that, I click on here. Then I can do this Save Toolpath. And when I do that, this option pops up. In this case, I could click there to get all of my visible toolpaths, but I only want the one. If I did click all 3 and click that, I'd get all 3, but I don't want all 3 for this example. So I'm going to turn that off. Now, post processors. These are all of the translator software for all of the different kinds of CNC machines. I shouldn't say all of them, for a lot of the ones that are available out in the world. And our machine in the back, the yellow machine, is called a CAM Master. And it has a single tool on it, a single router motor, and we're doing it in inches. So I want to pick that post processor. That's the one I want to translate to, because that's our machine in this room. When I say Save Toolpaths, I'm going to put it on the desktop, and I'm going to say simple G code sample. I use the word G code because that's the industry term for these translated files. And I'll explain in a minute when I open the file, but I'm going to call it a G code file because it's going to save all of the format in XY calculated mode that the industry calls G codes. Watch what happens. When I minimize this, I'm going to find that type of file. It's really just a text file. When I click on it, I want to open it up in Notepad. If I open it up in Notepad, here is the G codes. This is the file that the machine needs. All of these terms, these are just sort of documentation, just giving stuff. That was the one I called. There's that material size, 4x2. Here's my first G code. I'm not an expert at G code, but G90 resets the computer to start in the 0th position. As the language grew, as this G code programming language grew, they started adding other codes other than G's. And one of the codes are M codes. M5 turns off the spindle just to make sure the motor starts off and for safety and stuff. M3 will turn it back on again. So there's another code. The S code sets the spindle speed. Remember, we set the spindle at 5,000 RPM. Well, this is the code that the program sends to the controller on the machine to make sure that the spindle is going 5,000. Another G code moves the Z up to the top, so it makes sure it's out of the way. Remember, we set the feed rate at 50. An F code. I know it's confusing that I call it a G code file because we have M codes and S codes and F codes, but here is the actual G codes. And for you math geeks, remember we started in the origin. G0 is like go to this location, go to a half and a half. Well, if you remember, we start here. We go in a half an inch in X and a half an inch in Y. Go there. Then the Z is up high. Bring the Z down. Negative 10 thousandths of an inch. We remember that from our toolpath settings. Then we go to a half and Y goes to 1.5. We go over here and then Y is 1.5. So the cutter goes up here. Well, you can see the arrows telling it to go up there. That's that XY location. Then I'm going to go to X 3.5, 1.5. Well, that's way over here. That's that corner. And then 3.5 and 0.5. All the while, the Z stays down. What's happening? It's cutting along that wind at that depth. Remember, pardon me, we wanted it. Oh, I didn't run my thing. Sorry. If I run it, that's the depth that it's cutting at in that location all the way around. And then 0.5, 0.5, it's going back to where it started. At that depth, at that location, it lifts the cutter back up and everything turns off and the cut's done. A G-code file is really just a programmed set of text instructions with more than just G's, M's, and F's and S's and stuff. But this is the actual file that we need to cut your keychain. Once I do all of that, if I was to run all of my file and run it all through the post processor and save it, and then this time I'm going to put it on the desktop, but I'm going to call it my entire keychain. This is where the math can blow your mind. If you do that, and then I go here, I'm going to open it up in Notepad. Now, watch. Again, similar things, set up the spindle speed, toolpath. Now watch the X and Y's. X, Y, X, Y, Z. Look at that. This is all of the math that took all of your all of your vector paths and made them into math. And this is the G-code file that will run that whole keychain. This is the file you need for that machine to execute your design from the vCarve file. It's not necessary to understand how it does all of the math. It's just kind of necessary to know that it will do all of the post-processing for you in here, okay? The last concept I want to show that will help, I think I have my wrong file loaded up, is if you click all of these, there's a clock here, and it will tell you approximate cut time. So right now, based on all my settings, it should take 3 minutes and 42 seconds to cut that keychain. It would be a courtesy to everyone in the class. When you're finished your final designs, try to check I think I said in the assignment maximum cut time about 8 to 10 minutes. We can't have people on the machine running for a half an hour while they do some crazy design with thousands and thousands of little vectors everywhere. It just isn't fair to everyone to get a chance on the machine. So, as a courtesy, when you're done, before you post process, double check your cut time. Make sure that you're not going to hog up the machine on everyone. That's it. I think if you've got this far in the videos, you're ready to make a G code file and cut your keychain. Take care. I hope it works.